Okay, sorry. So that's the, okay. Are we all here? Oh, sorry. Okay, yes. So, okay. So we are ready to go. Oh, wait, more people. Okay. 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 Um, so okay, we can. So I'm almost. I'm more ready than usual just to get rolling here. I mean, just to get into the physics. I will say, partly why hopefully we can just get into physics is you guys are great. Like um, 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 I have a lot from all of you. Hopefully, you have your stuff back from me. Like I think we're all caught up to each other, which is good. And you're about to get a break too, because now we really have to start having me catch up in class to the material we're going over. Oh, but just one thing I did find over the weekend, I realized where I created so much confusion with the average acceleration sheet number 4. Like I once assigned it, but then it was buried and I even couldn't find it. So just to make clear for the record, no, there is an assignment called homework 4 called average acceleration. In theory, it was assigned already or something like that. Nobody is late with this. If you have not looked at it yet, you are not late. Like we're going to start getting into things where we can start discussing it now. You're not late if you haven't done it yet. And it'll be easier and easier to do it starting soon. And you won't get anything new due for a little while. Like, so most of you are up to average acceleration, homework 4, and that's totally fine. Like if you haven't even looked at it at all, it is totally fine. It is about time to do that. But also just to be clear, like about 5 of you did hand it in and it's totally, and got it back. And thereby they showed it can be done. It can be done. And so this is just my usual way of saying nobody's in trouble, nobody's done anything wrong. But sure, if you happen to be ahead of the situation or on top of, or you did the right thing when you thought it was the right thing, please know that I know it. And I do think that's literally 5 of you in this case. Okay. Still with the with the all the a game assigned. So what's due Wednesday is start on homework 4. We still might not even get to talking about too much of it Wednesday. So for some of you are getting into this habit, and it's fine. Like if you want to do some of it that you feel like you can do and just hand it in, so I see that you did that, and then you want to do some of it later, when that's fine too. As some of you may be noticing that I'm taking too long with this, but if you ever get a comment on any of your homework that says anything, or even those, well, maybe not the game assignments, but if you get a comment on any of your homework that says something like, for full 50 points, please, da 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 da, I'm literally saying there that could happen anytime. It's not saying you're late for having not done it. It's saying, here's a way to get a 50. Okay. But I think everybody's rocking, and nobody seems particularly behind to me or anything like that. Um, so but please do. So I'm going to start rolling, but please do stop me with questions about anything, logistics, grades, or the actual material. As far as the actual material, it's going to start picking up a little bit, but it's only just started getting mathematical recently. Like if you're keeping track, as far as I'm concerned, we have one equation so far, like no more. That means I'm not expecting you to know anything more than that so far. But okay, so if that's okay, or yeah, maybe could. So I'm going to go. Oh, so what am I about to do right now? I do want to discuss the train of thought assignment, because most of you have done that and took a while with it, and you might be wondering why I even assigned it. But I want to finish one last problem before we do that. We have one last problem. Yeah, on the average speed sheet, like where we ended last week was the uphill downhill thing, and we beat that to death. And I mean, it's really important, and we may want to come back to, we will come back to aspects that we learned from it, but I'm sure no one really wants to be talking about that anymore. But you may have noticed that the very last sheet, so the very last problem on the average speed sheet is a problem very similar to that one, that tests if you really got the concept of that. It's like maybe even one touch more tricky, but it's a similar thing. So I want to quickly talk about it right now. That is, I'm talking about this. Hey, you guys are going to remind me, please, a minute. I'm trying to just sketch what I remember the situation to be. Please, again, tell me if you don't know where I am or if this is a wrong place to be or something. But what I think is we're talking about this last problem on that homework too. So again, most of you are way ahead of this now in terms of what you've already done, and that's great. But we're talking about Grandma Grimm, where the situation, I believe, is we have Goldilocks or some character who's got to go. Sorry, has got to go 80. And please tell me if I'm wrong, but I believe it's 80 kilometers to Grandma's house. If someone could weigh in.
Yes, 80.
Great, thank you very much. Perfect. Okay, thank you. So, okay, so that's the one-way distance. And we know she's going to do that, and then she's eventually going to come back, and we're not worried about, she's not going to take any appreciable amount of time to turn around or anything like that. We're not worried about that. So it's 80 kilometers out and it's 80 kilometers back, very similar to the other problem, round trip, right? And then the one fact that we're given is on the way out. Maybe I'm gonna start doing this, making it look more and more like equations now. Like on the way out, we say that her average velocity was, I believe we did this in kilometers per day, I think, not in kilometers per hour or something, just to show that that shouldn't matter. Tell me if I'm wrong. But so she goes out at 40 kilometers per day. It's 80 miles. The question for this whole thing is, right, just this is essentially the question, I think, right? And I'm trying to say V round trip. Right, like this is the question ultimately. Given the givens, given that diagram, given an 80 kilometer distance on the way out and thereby an 80 kilometer distance on the way in, given that we're told that she goes an average speed or average velocity of 40 kilometers per day on the way out, then what the real question is, if we're to guarantee an 80 kilometer per day round trip average speed, what must be the speed that she goes on average on the way back in, right? So this, and I know everybody knows this. One reason I'm spending a little time to try presenting the problem again, even though you've already done it, is more or less what I have here on the pad is kind of like what I would ask you guys to do when you're doing a homework problem. Like give a little sketch like this and try to reduce and try to put down the facts of the problem and try to, like, you notice I'm not recopying the whole problem. I'm not recopying the whole problem. I don't want to any more than you do. But I am trying to put down just enough of the summary of the problem so that someone looking at my answers will know what they're answering. In other words, this is a good way to do homework. Side note on that, because I know I'm being really, if I haven't given this speech already, or two quick side notes. Number one, if I ever write BCF in your homework, I might have put a note in the Google Stream. I'm not sure, but if I write capital B, capital C, capital F anywhere in your homework, that just means be careful. I mean, it's a stupid abbreviation, but which just means that be careful. Like it might mean you just did something wrong. It probably does mean you just did something wrong, but it means you're doing something that is totally reasonable that I get. If I say BCF, like I get what you're saying and I'm with you and you're clearly being responsible, but you are doing something like either wrong right then or it's about to be wrong. And maybe it's a thing that we're going to talk about in class. So pay attention. That's what BCF means. Similarly, WWJ, no, I mean, sorry, that should be. But what WWD means we will discuss in class. Maybe I said this already, but on that note, in terms of doing homework, again, since you guys are on top of it, and you're going to get a lot of points for these homeworks and you're going to understand a lot because you're doing it and keep doing it, please. Thank you. I make this whole big deal how you have to do homework on separate sheets of paper. I've been making that big deal like forever, way before online teaching and COVID and all that. I had all my reasons. I don't want to get into all my reasons right now. I mean, they mostly have to do with, you have to give yourself space to do work, but I am realizing it's very annoying. I get that if you're sitting here trying to do my homework and you're doing it on a tablet, or which is probably preferable, or, you know, with a stylus or whatever, if you're trying to do my homework, and especially you're trying to make it low drama and just like do it within Google Classroom and just submit it, I realize it's very hard to do my homework. I realize the easiest way to do my homework is straight on the sheets, which is exactly what I'm asking everybody not to do. But I realize that the reason it's easy to do that is because then you can see the questions. And it's really hard to do my homework if you can't look at the questions while you're doing them. I get that. And turning back and forth between two documents is super annoying. I did not used to understand that, but I do understand that switching back and forth between where you're doing your work and what my questions say, like on one device, even if it's like a freaking, you know, desktop computer, is super annoying. So here's one piece of advice to get around that I welcome you to do, if it helps. You can take my questions, you can take the doc. I know this is all a big digression, I'm sorry, but you can, again, this is coming from the fact that your homework is very serious and good, and I'm trying to take it very seriously. So here's just a tip. What you can do is take my questions, my question sheet, whatever, and say that you just like loaded that in, say you just have them in your whatever device you're using, and you, assuming you're already technologically capable, if you already knew how to write directly on my documents, like with a stylus or typewrite on them, and I'm telling you not to, but if you already do know how to do that and it's making life easier for you, but I'm telling you not to, here's a compromise. If you already know how to just write directly on my documents, then just what I'm asking is just add blank pages. Take my document, take the question sheet, and just add blank pages and do all your work on the blank pages right after, if that makes sense. So you can use my document as the document that you're working in, but just give yourself blank sheets to do it on, so you don't squeeze your answers into. Hopefully you understood that. It's not worth talking about too much right now, but if that makes any sense, please feel free to do that. That's like now how I'm doing my solution sets. I get that it's impossible to go back and forth between two documents. You need to see that, but it's also impossible to do physics properly, squeezing your thoughts into like little lines. So anyway, this is what maybe would like look like a homework if you were doing it, like you sort of summarize this way. Someone's coming in, I'm sorry. But now getting back to the problem, this is very much like the Hill figure problem, in that we have a round trip and we're trying to do something with the average speed for that round trip. Here we just happen to be given the ultimate average speed and we're looking for one of the particular leg speeds, whereas in the other problem we were given the two leg speeds and we got an average. Okay, so same thing is going on here though. Like and again, please stop me if you don't get the question, but I think you do. The question is, how fast should we come back so that the whole thing averages out to 80? And of course, the instinct that many people have when they see this question, the basic first thing that might occur to your brain is like, oh, 120. I mean, there's other things too that might occur to your brain. Maybe even 160 occurs to your brain or something like that. And those are reasonable things to occur. If you're thinking in your brain, oh, one way is 40, I want the whole thing to average as 80. So then the back thing has to be 120. You're not crazy if you're thinking that. In fact, you're definitely understanding the question and you're definitely in the right class if you're thinking that. And that is what you would do if I said to you, but it is wrong, right? Like this is why we're talking about it. And it's wrong for reasons that hopefully you see, or you will see, or you will have seen after last class, like not unfair reasons, but it does seem weird at first. So let me make clear from what we learned in the last class. I mean, in principle, if you had two exams in this class, and on the first one you got a 40, and you wanted your average in this class to be 80. If you had two exams and you wanted your average to be an 80 in this class, and you got a 40 on the first one, you would be right to think, oh crap, I need to get 120 on the second one in order for me to have an 80 average. And you might even think, oh crap, that might not be possible. I need extra credit or something. Like that would be the correct math. If you have a 40 and you're looking for your average to be an 80, you would want the other test to be 120. That is totally true. Here in this case, if we want our average to be 80 kilometers per day for the whole thing and we go out at 40, we do not want to come back at 120. And the thing I want you to see, even if you already see that, I want you to see that 120 is not the right answer here. But I also ultimately want everybody to see, here's the lesson from last time. It's not because actually we're making up some new weird notion of the word average. It seems like we're going against averages by saying you can't just average the two speeds, but we're really saying that averages mean something deeper than that, and averages have to be averaged. Average speeds have to be averaged with respect to time, and we have to take time into account. So I'm going to quickly, so even though again, I hate to, I think some of you totally already know this and this is boring, and some of you may be confused enough that this is not helpful. And so please, either one of you stop me. But what I'm saying here, just like the last problem, is if our goal, if we want average speed for the whole round trip to be something, we have to remember the definition of average speed. Like we want the total round trip distance over the total round trip time and again, by the way, once I get through this problem, I'm sort of trying to blast through it because I think it is similar to the last one, but then we're going to go over train of thought which is homework 3. And that's going to be much more for anybody that's going to be more discussion oriented, less me lecturing, hopefully, and more talking. So you can plan your bathroom breaks accordingly, I guess. But I know I'm just like babbling right now, but we want the total round trip distance over the total round trip time. We want all of that to equal 80 kilometers per day, right? And that's the only definition there is right now of average speed, is total distance over total time. So, okay, in this case, we have different information from the last problem. Like we actually know, maybe I'll pause here and stop. It's not a trick question. You might find this to be a condescending question, but what is the total round trip distance here in this problem? If anybody just wants to put in the chat or say, or anything for the 50 points, what is the total round trip distance for this Little Red Riding Hood problem? It'd be good if I even... So I'm going to ask again. So this is the question for the class. Feel free to unmute or whatever. It's not a trick question. It is like a are we paying attention kind of question. So you might want to catch yourself. But I'm just asking, what is, for this case, for this, given the given information, what is the total round trip distance for this particular problem? Yes, totally. That was really fast. That's awesome. And yes, I'm saying yes, but anybody can still put it in the chat, even though I just said yes to 2 people that I just saw. Anybody who's still paying attention, it's not a race as such. I'm agreeing, but like, let me just remind you that yes, I mean, I see 3 answers in the chat that I totally agree with, and I'm really impressed. Just know, if in your heart of hearts, if right now you actually get why that is the answer to this question, if you put in the chat right now, you might think that's so dumb. He just knows that I just put in the chat because somebody else put that in the chat. But I would still know you're paying attention right now, right? Like someone else who's literally down the street at the COVID safe tavern having a COVID safe beer right now, like they would not know to copy the number 160 into the chat. So any of you who are saying 160, I totally appreciate, and it's still not too late for someone, but yes, the total round, that's what this world has come to. And I do not know what a COVID safe tavern is, but yes, the total round trip distance is absolutely 160, as you're saying in the chat. Thank you, Catherine. Thank you, Molly. Thank you, Jean-Pierre, and thank you, yes, thank you guys. It is 160 because it's 80 there and 80 back. That's for the whole thing. Okay, now we want that to be, remember, now we're sort of working backwards here, only because the information given in this problem is sort of backwards compared to what we were used to yesterday. But remember, we're saying that we want for this whole round trip now, this whole round trip, which we know for a fact to be 160 kilometers. And we're given, the premise is we want our average the whole time to be 80 kilometers per day. And you can imagine something like that. Like maybe that's a fuel efficiency thing. Like if we go any faster, like we'll run out of gas and then we'll die. I mean, we'll dye our shirts purple because we like to do tie-dye. But like, so we want the whole thing to be 80 kilometers per day as an average, but we know the whole thing is 160 kilometers. So we can right away rearrange this right? And we can say total time, this is just like we did yesterday. The total time presumably equals 80 kilometers per day all over 160 kilometers, right? I basically just multiplied both sides by time, and then I divided both sides by distance. I'm saying if distance equals rate times time, and if rate equals distance over time, then time equals distance over rate. Like you can rely on that. Whoop, sorry, except I just wrote it back. I said it right, but I wrote it backwards. Sorry. My bad. Someone should have stopped. That was totally to see if you were paying attention. My bad. This is what I meant. And this makes sense to, in other words, I'm saying up here, if anybody, for the folks at home, I'm saying, okay, I mean, anytime we get an equation in physics, when we get one equation in physics, we figure you could do anything you want to it that's algebraically legal, and it's still a true equation. So, even though the only thing we know right now is like average speed equals distance over time, but I can rearrange that any number of ways to get whatever I need. And right now I'm doing that thing where I rearrange it and I say, okay, time is distance over rate. But then, and the units do work out. If you remember, and I'm always using this also in this class, remember when you, I know everybody hates this, but remember when you divide by a fraction, you multiply by the reciprocal, right? Just like 2 divided by 1/4 is the same thing as 2 multiplied by 4. Like I'm always kind of using that in this class. So here, like if we divide by dividing by days, the days flip up. I know this, again, this is all of this stuff is like when you get it, you get it. But when you don't get it, it's so confusing and annoying. So I'm just talking to everybody as best I can. 160 divided by 80 is 2. But kilometers divided by kilometers per day does give you days, right? It doesn't give you, like the days flip up to the numerator because what we have here is something being divided by something over days. So long way of saying, this is not an answer to the question at all. We're almost there, but this is a piece of information. I'm saying if we're, and a lot of you got this, this is an important step toward getting the answer. It's saying, oh, if we want the average speed for the whole thing, for the whole round trip to be 80, what that in effect means is we want to do this whole trip in 2 hours. I mean, in effect, that it precisely means that if we want the whole round trip to yield an average speed of 80 kilometers per day, since the whole round trip is 160 kilometers, then it must be the case that the whole round trip has to take us exactly 2 hours. Like that is what our goal is, right, of this problem. Therefore, there's only one step left to do. Right. And again, oh, sorry. Oh, cool. Oh, thank you. Awesome. Talk about showing that you're paying attention. I thank you, Catherine, for what's in the chat. I see that. Good point. Thank you. And I was totally not doing that on purpose to see if you were paying attention. Great. Thank you. Great. Yes. So the whole round trip evidently takes 2 days. And then what I'm trying to say to everybody, and again, I'm trying to say something that does make sense. Like once you think about it, well, anyway, I'm trying to say, excuse me for a second. I'm trying to say from over here in the corner of the room that if we know what the whole trip must take and we're looking for what the back in trip must take, I'm thinking take that the amount of time it takes to come in, it must be the total minus the amount of time to come out. Like why? Because the whole total trip equals in plus out. Right. So all we got to do is find out how much time we took to go out, and then whatever's left over, like whatever we used up some time to go out. Whatever's left over to make 2 hours is what we'll have to take to make the trip back. Right. It's going to, so in other words, so the only question left is what, oh, no, Catherine's back. I mean, time in, sorry, not distance. Catherine was just being polite, not pointing that out, giving somebody else a chance to correct that. Right. So now the only thing left is, okay, and again, I know many of you see where this is going. The only question is thus. Oh, sorry. Right. Again, just doing the same thing. I'm just saying time equals distance over speed. And here's the problem. Well, I think many of you know where this. Here's the problem of the problem. We're doing everything we're doing right. We're just finding out. We're about to find out that our answer is kind of strange. Just that, not that we did anything wrong, but that the situation is strange. Why do I say that? Because the distance out is 80 kilometers, and the velocity, the average speed or the average velocity out was 40 kilometers per day. So the problem, yes. Oh, wait, let me see. Oh, interesting. Okay, hold on one second. I'm seeing some things in the chat that are interesting. Maybe I should pause here for a second. Like, I think we're about to get an answer if we're following our procedure. Like, if I solve for this and then I subtract from the total, I'll get an answer. But it is definitely, but you might find the answer very confusing. It is a confusing answer. It's an answer that suggests that something is weird somewhere, but it's not weird in our work. But I'm getting a couple of chats. So let me, from you guys, so let me just respond to this. But think for a minute what. What it seems, what this part says here. to cut to the chase, oh, yeah. Sorry, I'm just looking at the chat. So yeah, here's what I'm saying here. That does seem to agree with what some of you are saying in the chat, and certainly agrees with what many of you who did this in the homework got this answer. Now, I mean, one reason I'm talking about this now is, again, it's like everything else in physics. Like once you get this, then hopefully it does make sense. I don't want, nothing in physics should be something that you accept just because we say it's like a magic formula or something like that. Like this stuff is, it's always a surprise to me as much as anybody else. Like the art of thinking of things yourself for the first time in physics is an art that we're trying to develop together for 2 semesters. Like, or the technique, the skill of like being able to figure things out on your own in physics. That's what we're here to figure out together, and it's a process. But seeing things in physics first, like seeing how they're not what's expected, but they do have to be that way, is like the stage we're on right here. So what I'm trying to say to everybody is, the answer to this question, the actual answer to this question is she would have to go at infinite speeds, or at infinite speed on her way back. If Little Red Riding Hood's mission in this problem, if her mission is to average the whole round trip at 80 kilometers per day, and if she starts thinking about this by the time she's gotten there, like if she already went out to the grandma's house and she went out at 40 kilometers per day at that. And if you don't like days and kilometers, obviously this whole thing in your mind, you can just say miles per hour in your mind and it's all the same logic. So if she went out at 40 and she's committed to averaging 80 for this whole round trip, what we are saying is the only way she could pull that off at this point, once she's gotten to the grandma's house, the only way she could pull this off is to get back driving at an infinite speed, which I'm not saying is or is not physically possible. All right, physically it's not possible. It doesn't mean this isn't a possible physics question though, right? It doesn't mean that this isn't a fair math question or something like that. It is hard, but what we're saying is, put another way, we could just slightly rephrase the question and say like, what speed, if any, would be necessary to blah, 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 or we could tweak it and say like, would it be possible or not? What we're proving here, what we're saying is, for her, there is no finite speed that would be fast enough to get her back in time to clock an average speed of 80 miles an hour or 80 kilometers per day for this whole round trip. Like what our answer does not mean this problem cannot be solved or this problem is not giving enough information. This problem is giving precise enough information to show us that the answer is it can't be done in the physical world. There is no finite speed fast enough, because she would need for this whole round trip to take 2 hours. She's already used up the 2 hours just to go out. That's what breaking this down slowly shows to us. Or like, as somebody put very cleverly in the private chat, like she better not waste any time talking to the wolf, or she's wasting time if she talks to the wolf. Like she's sunk in the water if she spends even a millisecond talking to the wolf. It's too late. She has got to get back in no time because she used up all of her time on the way out just because of the way the numbers say. Again, it's showing that average speed, what it's really trying to show, and then I'll shut up. It's another example of how an average speed is an average. It is, but it's an average that's weighted with respect to time. So it's like it's a more careful average. It's a very correct. It's such a correct average that if we try to get that average with approaches that are not careful enough, we won't get it. Like 80 plus 40 plus 120 divided by 2 does give you 80, but that is a valid operation. That's a valid way to look at this mathematically, if and only if she spent the same amount of time going a speed of 40 as she did going a speed of 120. What we were trying to show in the last class is that if she comes back at 120, she's spending less time doing 120 because it's a faster speed, then she's spending less time doing 120 than she is doing 40. So it's not fair to average them equally. Like 120 should count more in the average. So it would be so if she came back at 120, she would average at something higher than 80. Anyway, so the answer to this is it can't be done at a finite speed. V would have to approach an infinite speed for her to get back in time. That's the answer to the question. I'm going to pause for a second. Let me just see if, and this is cool what Noelia is putting in the chat and totally points, obviously. Yes. Wait, she's trying to have the distance. Yes, that's right. That's right. What Noelia said, that's cool. Half the total distance at half the total speed, totally true. Yes. All right. These last two questions, if they feel a little bit like trick questions, I understand that. They are a little bit like trick questions, and a little bit, all of physics is a little bit of a trick question in the sense that physics is always simple, but it's always much simpler than we think, but less easy than we think. Physics is always a little bit tricky because it's about things that we should actually be able to think through, like as opposed to memorize a bunch of stuff or know a bunch of stuff. But we actually have to think through super carefully and take definitions super seriously. Physics questions will always be a little bit like this. I have to apologize in advance. They're never meant to trick you. They're meant to show you something that's tricky in the world, and you get used to them. I think of these two questions to be totally fair. I think the second one comes closer to being kind of like a trick question than the first one. The Hill figure one it seems like a trick if you just rush in and try to average the two numbers and you get the wrong answer. You feel like you're a little bit tricked, but I think most people can understand after a while why it's fair. This one I understand seems even more unfair because the answer to this question is like it can't be done, and that seems like it's saying the whole question is stupid. I respect that. Like I don't really feel that is what the question's saying, but over years of using this question, I do understand that it bothers people. So let me also tell you that won't happen a lot in physics. Mostly we will actually get answers like you could do it, you can't do it. But we will deal with infinity a lot in physics. In fact, starting tomorrow, we will deal with infinity. We don't want to run away from infinity. Saying that a car would have to go infinite speed in order to accomplish something is a perfectly valid thing to say in physics, even if then we turn to our engineers and say, because the physics says that the car would have to go at infinite speed, that means we can't do it because we can't make cars that do that. Like totally true, we can't. I mean, we literally can't, but it still is a physics result, if that makes sense. So we do have to deal with infinity in this class. All right, yada, 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 yada. I'm going to pause and I'm going to pause. What I'm going to do next is turn to the to the train of thought sheet, and we're going to start talking about that. And that's more of a talky thing. So like, please take that out or whatever, the train of thought sheet. But while you're doing it, I'll just pause to see if there's any questions or anything at all about any of this, either this problem or homework or whatever. We're just going to like silent medit. It's 11:30. Oh, we got time. Yeah. So I'm just going to literally be silent for like a minute while we switch to train of thought and while you see if you have any questions or like look this over or anything. You can imagine these last two problems. I don't generally do this, but if you really want, if you were getting this or seeing what's going on or getting bored, these last two problems are the kind of problems where you can make up the same, you can change the numbers, make like the identical problem, but just change the numbers to practice yourself and see if you get it. And that's the kind of thing I would do for an exam, is like these two problems would be valid to just change the numbers and make as exam problems. Frank, you'll see when you get your practice success for an exam, like what's actually on it. And to be totally honest, probably these two won't be. They're a little bit too short. But things like this is how we make exam problems. So anyway, I'm going to move to the train of thought thing now while you just let that. So you might want to try plugging in different numbers and seeing what you could do, like either now or at another time or whatever. But okay. Okay. So let me just see if there's any questions. So could I just get like thumbs up or electronic yes or saying if it's cool for me to move, if it's clear and cool for me to, okay, thank you. Thank you, Molly. That's great. And thank you, Antonio. Oh, I never even saw that. Yes, check. That's cool. I didn't know about that. And thank you, Noelia. And I hope I'm pronouncing it right. Thank you, Alyssa. Okay. And thank you, Catherine. Okay, so we're gonna thank you, Daniel. All right. I know this is so, I know it's like kindergarten, but wasn't kindergarten so much more fun than college anyway? No, probably not. Not depends who you were. Okay, yes, and it. No, I tended to get the crap kicked out of me in kindergarten. Actually, you can imagine. Okay. Not because I was weak, but because I was obnoxious. No, because I was weak. Okay. So we're gonna do train of thought. Good. Thank you, guys. All right, we're gonna do train of thought. One little, so it starts with asking you to sketch some things out. Oh, I've been trying to say that in homework. Please always, even if we were forget to remind you, like when you open up a new problem set or anything, just try to open up with a diagram. Always try to start with a diagram. It really does. I'll get more specific about that, but it's really a good habit to start with a diagram, even if it means basically copying one that was given in the questions. But you really do want to, that's what makes it physics, not math, is that it's actually about the physical world. So here we tried to actually guide you with the diagram, and we asked you to make a list of features. I won't get all involved right now why we asked for that list, but I will just say some of you might have noticed that you might have gotten a 49 rather than a 50 on this homework, just because I'm such an annoying person that I held you accountable if you didn't actually follow that instruction about putting down the list. That's me being super obsessive, I know, but if you look at your homework and you only got a 49, and if I said something about a list, what I'm talking about is right on the first question, where it asks you to make a diagram. It first asks you to sort of organize your thoughts for that diagram first with a list. If you happen to be a person that didn't do that, or I didn't see it, just give it to me, and then you'll have a 15 out of 49. It's like no big deal. There is years of research. I'll explain at some point when we have more time why. Like I've done a lot of research about this particular exercise called train of thought, like papers about it and stuff. And I've taken data from classes, not from you guys. I'm not using you in that way, but there's a lot going on with this train of thought thing. And it turns out that that the diagrams are very hard to get any information from unless you have some direction. So whatever, for an extra point, just please do that. But then some of your diagrams were gorgeous and all of them were illuminating, but you drew this diagram, but then here, when we get to the main point is you clearly understood them. The main point is that you're in this train. Maybe it's a fantasy, maybe it's a dream, or maybe it's reality, but it's Tokyo where the trains are really, really slick. And like, there's no direct evidence as to whether you're moving or not. And you're asked a series of questions like, are you moving, or are you not? So here's what I want to do in this class. I do want to have a discussion about this. First, I just want, who voted? Just raise your hand if you voted for, in the initial stages of this, like on page 1 of before the white lights and everything, if you voted for, yes, the train is moving, could you put your hand up electronically or something now? If you voted yes, the train is moving. Okay, okay, cool. And you guys can see who's raising, right? Okay, one person, cool. 2 people. Okay, 2 people said, and again, to repeat to everybody, and I'm going to turn it to you guys again in a minute, but we're saying on the train of thought assignment at the beginning, right when it first asks you, like, are you moving or not? Like 2 people they said, yes, it is moving. Or 3 people. Okay, Antonio. Okay. 4 people said it was moving. Okay. So, and that is my question for the moment. Like initially, I'm not asking what's right or what's wrong. I'm just asking like what you did at that point in the homework. About 4 people say they said, yes, it's moving. I think, or maybe it's 5. Maybe it's Alyssa, not you. I'm going to ask this again. Let me ask it differently now. So maybe put your hands down now for a second. Now, how about raise your hand if you said it is not moving? And I'm talking about like the first time you're asked this. 1 person. Okay. So again, we're saying not moving. I got 1 person, Ashley. It's for not moving. So far I'm thinking we have about, and I promise no one's going to be just like not right over. Thank you, Ashley. Okay. So like 5 people said that yes, it's moving. 1 person said like, no, it's not moving, I believe. Now raise your hand if you said any of the other answers, like not enough information or both or neither. Any of the others, raise your hand. Okay, we got, okay, Daniel, Catherine, Nikaya, like 3, anybody else? But wait, this is a little concerning now because I feel like we have not accounted for everybody. I would like everybody to vote for at least one. I think there's 3 options. Oh, and you can put your hands down now. Thank you. Like, I get that Catherine and Nikaya and sorry, and I think it was Daniel or one other person said like both / neither / not enough information. Hopefully everybody's paying attention. Oh, no. Okay, okay. And this I think we really can go public with. Like there, I think, okay, not cool. This I'm hoping everybody votes publicly. Like I'm gonna do this again because there's 3 options. I mean, I know there's 5 on the sheet, but there's yes, it's moving. There's no, it's not moving, or any of the other answers that say some kind of both or neither. Like those are my 3 options for now. I would like to see everybody vote one way or the other. I'm being a little bit obnoxious now. Like if you could return from a bathroom break, like whoever you are, it would be great. In fact, I might even in a couple of minutes try to turn this into enough of a discussion that I encourage more videos. Maybe I'm going to promise you in advance, there is a point to this whole train of thought thing, but there's not a right or wrong answer as such. No one is going to be shamed for like voting the wrong way. Like there is no wrong way to vote. There is a point, but there's no wrong way to vote. So let me say again, we're going to do a vote of 3 options. It is moving, it's not moving, or we don't know. Like it's both. It's in other words, option A, option B, or C, D, or E are all grouped together. So let me do this again. Raise your hand, please, if you think initially the train is moving. Okay, that was fast. I see how, wow, and all the things are, oh, wow, okay, that was really fast. Great. Oh, great, thank you. Hold that thought. Don't put your hands on there for a second. I'm just repeating one last time. Like right now I see 7 hands, which is awesome. Oh, it even tells me I'm seeing 7 hands for it is moving. And that's great. Now you can put your hands down. Thank you. That's awesome. That's 7. Okay, cool. It's funny. Oh, I see what happens. Right. Okay, cool. So you guys can, oh, there were, oh, a couple more people. Okay, you can put your hands down now. That was all voting for who says it is moving. You can all put your hands down now, please. Or maybe I can even. Okay. Wait, and please, I'm going to ask it. So please, everyone, put your hands down now for a moment. Thank you. Okay. And there's one more, and maybe. No, I just did that. That was okay. Now I'm going to ask. So I think that may have been actually 8 people. Okay, that's cool. But now I'm going to ask everybody who says, no, it's not moving, please put up your hands. 1. Okay. That was fast, by the way. I appreciate it. So it's 1. So 1 gutsy, fast, thoughtful person for it's not moving. 1. Okay, cool. Thank you for putting your hand down. I saw that, Ashley. Thank you. Okay, now hopefully this is going to be everybody else. If you're listening, if you haven't voted in the last 2, you sort of have to vote in this next one. This next one is if you don't vote for yes, it's moving, you don't vote for no, it's not moving, you vote for like not enough information or it's both, or yeah, anybody who's saying any of the other 3 options, please put up your hand now. Okay, I see 3. That's awesome. 4, I see 4. 8. Okay, that's good. I see 4. I want to say to everybody, it looks like, unless I'm crazy, there's 18 people in this class, not including me. So we got, I'm willing to say 8 on the first and 4, 12. We're still missing some people here. Somebody's not voting. And if I were the kind of person to want to deduct points for class participation, which would be absurd, and I would never do that, but like somebody should be, if ever you should feel ashamed, you should not feel ashamed for the way you're voting. But if you didn't vote at all in this, that's a bummer. You want to vote. I mean, you want to take one of the options. I don't think everybody's voted. I think there's 4 people missing, but okay. Right now, at least more people. Okay, thank you. Thank you. Okay, but now you can all put your hands down now. What I'm seeing so far, thank you. What I'm seeing so far is, if nothing else, there's kind of a divide here, right? Like, and there's a reason for that. Like about 7 or 8 people said, yep, it's moving. About 1 guts person said, no, it's not. But and then about 4 people said, well, we're not sure. We don't have enough information, or it could be both, or it could be neither. Then there's at least like 2 or 3 people that I think didn't vote at all and maybe would have voted with the 1 person. I don't know. But it seems like every view is represented here. So I think, wait, let me just, before we go any further, I know this takes something. I promise you there's a reason we do this exercise. A lot of reasons. But let me just start with, does anybody want to give a reason for their vote? Whatever you voted, does someone have the courage to explain their vote to anybody in the room, like ideally with voice, but you could put in the chat too, I suppose.
I'll do it since I was the only person that said no, it's not moving.
Go for it. Cool.
Okay, I'll turn my camera on.
Oh wow, awesome.
Okay,
Oh, you get so many points for this. I can't even tell you. Okay.
So I said it was not moving just because my list, I have like the floor nor ceiling has no distinguishing feature, so you can't even tell the difference towards like the front of the train, the back of the train. You can't tell where you are on it. And then the thing that really got me was the senses. Like you sense no bumps, no lurches, no turns. So there's nothing to decipher that you're necessarily moving. So I thought the train was like not moving. That's what really got me. So I thought it was like standing still for a second, or it like, yeah, I thought it was like standing still for a second. Necessarily, like maybe it was moving before, or like it's going to move, but at that exact moment, I thought that it was not moving at all.
Totally. First of all, I totally appreciate that. I want to say to everybody, I think that makes complete sense. There's not there. I don't see anything wrong with what she's saying, with what Ashley's saying, which doesn't mean that other people can't also say stuff, but it does seem to me it's a perfectly legitimate, like valid argument that she's making. And I really am impressed. Like this does happen a lot, especially, I mean, if we were ever in a classroom together, like I like these discussions, and often one person will be on their own side in a physics discussion. And it's super important whenever we have a discussion. If there's one person on the side, believe me, we always want to hear from that person, because it's very frequently the case that if you're by yourself in a physics point, it is not because you're wildly wrong and off in crazy land, like not in physics. Like in other words, majority doesn't rule in physics. So it's super important what Ashley just said. I don't think I could find anything wrong with it. Doesn't mean we're done. Like I would like to hear from someone who voted, and this is not a challenge. I mean, it's a challenge, but it's not like a bully kind of challenge. But like I'd love to hear from someone who did vote that the train is moving, and say whatever they thought. Like they can take into account what Ashley just said or not. But I would just love to hear now what someone said on the other side, just so I can put up the two arguments in my mind and look at both of them at the same time. So we've got Ashley on the one hand. Oh, sorry. Yeah, go. I'm sorry. Go.
Oh, okay. I'll turn my camera on too. So, my reasoning for saying that the subway was moving was because it said that it was a southbound train, and usually when you're in the subway, like it's underground and you're going at like a constant speed. So you can't really feel that it's moving when it is going at a constant speed, unless it's slowing down or speeding up in the beginning or the end. So maybe like it was in the middle of the ride it was happening.
Oh,
That was my only reasoning.
this is great. No, this is great. And again, I totally appreciate that both of you are doing this and putting on videos and everything. This is Ashley and Molly. So wait, let me summarize what we have so far. I'm not going to use their names. So we have, first of all, like Ashley's argument, I'm not going to write Ashley, but Ashley's argument is, and this is totally true, there is no evidence to suggest nor confirm motion. Like I want to be very specific about this. I mean, this is why this is interesting to me. Like on the one hand, what Ashley is saying, remember, we're scientists. She's saying on the one hand, well, you want to know whether we're moving or not. Let's look for like some evidence that we're moving. The evidence could come in any form, a bump or a lurch or a turn or something in the seats. But what Ashley listed all the things and saying, well, there's nothing that you can point to that would suggest motion. And even though Ashley knows it's a subway, so she even did come up with some explanation for why you could be in the subway and yet not be moving. And the answer is like, you were moving before and you're going to move now, but maybe at this moment you're not. Like that's totally reasonable, Ashley's view. Now then Molly, I think it's, Molly comes along and says, and here's the thing, like, here's why Molly's point is now equally valid. And I literally mean equally, like why this is worth discussing to me. Because Molly does not come up and say, oh no, Ashley, that's not true. There is evidence to suggest motion. Like she literally does not dispute, and she shouldn't. I mean, I'm about to write down what Molly said is totally perfect in its way. But just notice that even though Molly and Ashley are on completely different sides of the conclusion, that there's actually nothing in what Molly could have gone first or second. And it actually wouldn't change what Molly's saying or what Ashley's saying. Like it wouldn't change the legitimacy of it, because Ashley's main claim is we don't have evidence to suggest motion. And Molly does not come along and say, oh, yes, we do. I mean, you know, if she did, that would be one kind of way of arguing, right? But she doesn't say, yes, we do have evidence of motion, like there is a bump or there is a lurch or blah, blah, blah. What she says very cleverly, I mean, intelligently, is
Professor, wouldn't you agree that there's like three other sides to this conversation?
yes, absolutely. In fact, yes, please go. Let me just finish writing the one and then go. Yes, I think I would. Oh, wait, 1 second. What's the side? Yeah, you, well, oh, wait, okay, I'll say this and then I want to hear what you're saying. Yeah, what I'm saying, right? No, there's definitely more than two. Right, there's definitely a number of sides to this, and there really is. Even though, by the way, this is fictional, like even though we're picturing a fake train, that's okay. We're not really picturing a fantasy. We're really picturing like a super optimized version of something very realistic. Like well, okay, that's a side note. Anyway, I want to hear Nick, the third side and the fourth side to this, but the one thing I just want to make clear to everybody is why it's even possible that there's two sides, even two. Why two seemingly contradictory points can coexist is that Molly says Ashley says there's no evidence for motion. Therefore, I don't vote for motion. That is extremely scientific, right? I mean, that's about as scientific as anything can get. You're being asked what you conclude, and you say, well, let me look at the evidence. Oh, there isn't evidence for that conclusion. There isn't evidence to even suggest or confirm it, right? There isn't even evidence, well, maybe to suggest it, i.e. you're in a train and trains make people think of motion, but nothing seems to be indicating motion. So Ashley says, I vote no motion, especially if you're asking me to vote, Yaverbaum. You're not asking me to commit life, but you're just asking me to vote, so I vote no motion. But then Molly says, I gotta let somebody in, sorry. But then Molly says, I mean, you almost wouldn't even think this argument could be out. If I were on Molly's side, I'd be like, oh crap. Now what do I say? That's a good point. There's no motion. There's no evidence. There's no evidence. Oh yeah. But what Molly says is, in effect, now I'm using different words, but what she comes up with is a realization that, oh yeah, but you know what? You could be moving. Like I could imagine scenarios where you actually are moving under certain conditions, and yet even with moving, you wouldn't be getting the evidence. Like she specifically says, not so much at the beginning of a ride or at the end of a ride, a train ride, but she sort of directs our attention to like in the middle of the ride. And again, we're not using numbers yet. We're not being highly mathematical, but what she's raising is, oh, here's an interesting thing is that there are circumstances of motion where there doesn't seem to be any evidence suggesting it, and yet you still know that you're moving. So it says, it's like saying there's nothing wrong with what Ashley's saying, but could we look at it a different way? So having said that, I think it was Nikaya who just asked me before, isn't there a third way? Go for it, with the other ways.
I agree with what both Ashley and Molly said. There is no evidence of the train moving when you first get up. There's no bumps, no lurches, no turns, right?
Right.
And then one can argue that the train is moving, but just at a higher speed, just like what Molly said, at a higher speed. So you're not feeling the lurches, the turns, or the bumps that's happening. I mean, that's not in New York, but as you said, right? So there's really no indication or suggestions that it confirms nor denies that the train is moving.
Yes, no, right. And I totally agree with that. And I also agree with, I just saw something. Yes, I mean, and I know, believe me, I know this is a science class. So, and I'm introducing something that I think has like sort of two sides to it and doesn't seem to have a lot of numbers yet. So it can feel very unscientific, I know, to people at first, like, why are we even discussing, like, what's the point? And I keep wanting to promise, believe me, like, we're going to stay in this for a little bit, because my true feeling is that science is actually really always this way. This is the way science, anyway, I'm getting off on my tear, but I believe there's many sides to this. I believe Ashley's side, I believe Molly's side, and I believe Nikaya's, what she's saying, her side. I still think it's worth it because we're still going to get somewhere with this. I promised everybody that the conclusion of this whole thing is not going to just be, and so you see, folks, it's all just a matter of our feelings and opinions. And in the end, if I say 2 + 2 = 4, but you guys say 2 + 2 = love, or 2 + 2 = anarchy, or 2 + 2 = 7, like that's fine because it's all opinions. No, I'm not going to say that. Like, we're in a science class, we're going to get somewhere with this. But I'm going to say, oh, this notion of motion, like if this whole science class, we're going to study motion, specifically like velocity, acceleration, all that, even beginning, let's really make sure we know what we're talking about when we talk about motion, because it's slippery. Even in this case, right, of being in a train. Okay, like Nikaya just alluded to, and like I alluded to before, trains in New York, they don't fool us that easily. It's true. It really probably has to be like the freaking A train between 59th and 125th to even fool you at all. Maybe, and maybe you have to be like very asleep. But here's why this is actually much more realistic than it sounds. Not only are trains a little bit more like this in Tokyo or DC or something, but also this whole thing about a train, about not knowing if we're actually moving or not. Even if that seems unrealistic, I think everybody in the room can relate this to elevators or to airplanes, right? Like when you're in an elevator, especially like Ashley said, when you're in, no, sorry, like Molly said, when you're in an elevator, when it starts at the bottom floor and you get on and it starts going, okay, you feel something in your stomach, you definitely know you're in an elevator, something weird's happening. But if that elevator goes a far enough journey, even the 10 floors at John Jay, like once you're cruising at floor 3, floor 4, floor 5, you know, you could close your eyes and you have no idea whether you're arriving or coming. And when the door is open, as far as I'm concerned, I mean, during that middle period when you're in an elevator, as far as I'm concerned, they could be bringing the building past me just as easily as they're bringing me past the building. Like, I don't feel anything in that middle stage of an elevator. And if I'm on an airplane, right, and it's dark and it's a long flight and the airplane's cruising, and they've told me that, you know, the captain has said it's safe to unfasten our seatbelts and to move freely about the cabin, I do, right? I'll walk around an airplane if I have to go to the bathroom. And if someone says to me, like, hey, could you pass the peanuts or whatever? If someone says to me, pass the peanuts in an airplane, I don't go like, all right, here it comes, get ready. Are you sure? Like I don't think of the fact that I'm in a thing that's 5,000 feet above the ground, traveling at like 500 miles an hour. I'm just like, okay, I'll go walk to the bathroom. And I don't think my drink is going to spill while I'm doing that. Like, if, you know, and I start complaining that the movie is bad or something on the airplane, like it's a hotel room or like it's my freaking apartment. But the thing is moving at 500 miles an hour. And I can totally fool myself into literally not even knowing if it's moving or not, or acting the same way I do whenever things are not moving. All this goes back then to Ashley's point, like you and Molly. I mean, this goes back to both points. You can be in an airplane and some part of your brain believe very strongly that you're moving in some part of your brain, but have zero evidence of that fact whatsoever. So much so that you do crazy things. And, you know, and like when you walk to the back of the airplane, if you're walking to the back of the airplane, I don't know if you ever thought about this, but if you're walking to the back of the airplane to use the restroom or something, if you jump up while the airplane, like if you just decide to jump straight up, you're not worried that the back of the plane is going to slam you in the ass on your way down, if you know what I'm, pardon my language, but right, like you just figure you're going to land where you jumped, and you're right. Or if you just toss a coin up in the air, it's going to land in your hand as it would in a parking lot. So there's some really weird way that motion can happen without any evidence of motion. And it really does raise the question then, like, how do we actually know whether we're moving or not? Does this make, am I make, which, so I'm basically agree. Oh, and so then I see in the chat, sorry, hold on, look in the chat. Right, so you might well, so one thing, so this doesn't mean, I'm still not saying, oh, sorry, I didn't write down Nakaya's voice. Hold on a second. summary of what we're saying so far, and so far what I'm hearing from the three of you, and I think it's totally right. Okay, this train is fictional. It is a hypothetical, but I think it represents very realistic things like elevators, airplanes, even cars on the highway. I don't know if you've ever had that experience where you're in a car on the highway and like maybe you're not the one driving, or a taxi or something. So like maybe you're not the one driving, or just sitting in the back, spacing out, spacing in. Maybe you're in traffic in the highway. And if you've ever had this experience where you like casually look next to you and there's some huge truck or something like blocking your whole view of the rest of the highway, and it's right next to you. And if you space out, this is a very specific experience, but I feel like a lot of us, I feel like it comes up a lot that people have had this, where you like space out and you're looking at that truck, and you see the truck all of a sudden slowly moving forward, like when you weren't paying attention. So you suddenly like wake up or something, think, oh my God, like we're rolling backwards. Like my foot slipped off the brake, or the driver's foot slipped off maybe this is too specific, but I feel like there's this thing where there can be a truck next to you. And for a moment you're like, oh no, the car is doing blah, 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 blah. But in fact, it turns out your car's not doing anything. It's just that the whole truck next to you is doing something. And I don't know if you know that experience that I'm talking about, but there's a lot of ways to be very fooled by motion, either to be fooled into thinking it's happening when it's not, or to be fooled into thinking it's not happening when it is. Like, I think the Molly side of things is one side, the Ashley side is another. And then Nikaya is right to say, I'm not even sure those are only two sides. Like, this is kind of a mess if we're just trying to even just figure out, how do you know when a thing is moving or not? Like, that kind of is the question here. So, and there will be an answer. Again, this is not just a vague, like, whatever we feel like, but it's important to see how to get the answer. So one thing I want to ask, a lot of you put like not enough information, very fair, like partly because of these reasons. Like there's not enough, because you could imagine that you could be in a subway under similar circumstances and you wouldn't know. So a lot of you put not enough information. But then the white lights came in to the discussion, to the sheet. And they added something to the sheet. And then I asked the question again, are you moving or not? So one thing I want to ask all of you right now for the next vote, so to speak, let me just get the time. And again, okay, we got 12:05. Just very fast. I'm just very curious. Well, yeah, very fast, because I know we have 5 minutes, but very fast. Just raise your hand. There's two options. Raise your hand if your basic opinion about the motion. Here's the two options I'll tell you. Option number one is if the white lights in any way changed your basic opinion about the motion in any way. So in other words, like a lot of you originally put not enough information. If when the white lights came, if you felt that was information and you now wrote, I am moving, or you wrote, I'm not moving, then that would constitute a change, or vice versa. Maybe some of you put, I'm not moving, then the white lights came and you put, I am moving. I just want to know, for a show of hands, the two options are, oh, okay, but I'm not even sure. Thank you, but I'm not, cool. But I forgot which option I was going to say first. Yeah, raise your hand if the white lights in any way changed your basic answer. Like, okay, that's one. Thank you, Nikaya. That's cool. That's two. That's Nikaya, Daniel. So again, I'm just repeating for everybody. And I know class is almost over, but you're raising your hand if the white lights changed your basic. If you basically view the white lights as giving some new information that helped. So that's three people. Three people said they changed their answer in some kind of way with the white lights. Thank you, those three. Thank you, Daniel. Thank you, Michelle. Thank you, Nikaya. Could you guys put your hands down for 1 second? Oh, interesting. Okay. So here's my other option. And Molly definitely that's cool. My other option is, did the white lights not change your answer? And Molly just interestingly put, like, they solidified. So that's a stronger version, but okay, yeah, cool. If your answer remained consistent with the white lights, I'm getting a lot. That's 5 people, 7. Oh, and you're definitely listening. Thank you. I totally see that people are paying attention. 8 people. Okay. 7. Okay, great. You can put them down now. Again, I want to continue this. I know you don't still see, I haven't told you yet why we've done this. And by the way, we don't need to have resolved this for you to try the next homework. If you haven't tried homework 4, please try it. You could just go as far as you want until you're stuck, like, and then put it down, honestly, because on Wednesday, I'm going to show you where this discussion is going. We haven't finished this discussion yet. So obviously we still have things and you don't need the results of this discussion. You don't need the results of this discussion to do homework 4, but believe me, it's totally understood that you still can, what I'm saying is there's no new homework. So those of you who don't finish homework 4 by Wednesday, it's still not a crisis. It will still be a little while before we're going over it. Where I'm going with this whole thing right now, just to give you a taste of why we're getting into this now. Those of you who, I agree, the white lights do provide, it's interesting, whether the white lights provide the kind of information that can settle the question is an interesting question. I want to continue with on Wednesday. But the main thing I'm saying right now, just to give you something to walk away with, is as fictional as the train is, as fictional or hypothetical as the train is, what the train is actually representing, why we're really doing this problem, it's not just to think about elevators or trains or planes. It's really to think about the original case where this first came up, where a bunch of people for a super long time really honestly could not figure out whether a certain vessel that they were in was moving or not. This is a real question from history. Does anybody have any idea what, in other words, this whole train is actually an analogy to something actually real in physics. The real dilemma that actually begins physics, I'll just leave you with this. You might already be guessing, but classical physics, Galileo, Newton, all the stuff we're doing, it all comes from people originally wrestling with the very hard, very real question of, is the frickin' earth moving? Okay, just anybody who's still paying attention to me, the reason we're doing the train of thought exercise, the train is an analogy to planet Earth. And you know, I know all of you know, oh, thank you. Oh, that's very nice to say. Yeah, it is kind of interesting. All of you know for your whole lives that for most of history, people did not think of the Earth as moving. And then at some point in history, people started thinking of the Earth as moving. That point in history where people started thinking of the Earth as moving, and it's very late in history. It's so late, and believe me, so late that everything we know about moons and suns and eclipses and all this astronomy stuff that I like, believe me, everything that people knew about outer space and phases of the moon, they knew way before they ever figured out that the Earth was moving. Like the shit that you can figure out about outer space and about the universe without even realizing that the Earth is moving is astonishing. Okay, so it's very, the evidence that the Earth is moving is very hidden from us, to put it mildly, right? And the idea that anybody even ever came to even wanting to believe that the Earth was moving, let alone being convinced, is how physics began. The beginning of physics is the beginning of believing, is getting our minds around why we would even think of the ground below us as moving at all, let alone, by the way, if you want to know how fast it's going like 65,000 freaking miles an hour. It's going really fast. So it's not just that it's so slow that we don't feel it. I'll get into that on Wednesday. But anyway, this train thing is really about the Earth. So and it really is where physics equations come from in the first place. So that's why we're doing it. I think what you guys are saying so far is fantastic. We will continue with this on Wednesday. I know we all have to go. I'm sorry to keep you, but I know but there's no new homework. If you're on top of the homework, you got a break for a while, really. And if you want to try number 4, great, but we're going to keep going with this. Okay, so you have to go. If someone just says, oh, I'll look in the chat, but oh, cool. No, okay. So I'm good if you guys are good. If you can just like say goodbye or
Bye, Professor.
bye.
Bye, Professor. Thank you.
All right, thank you.
Have a
Guys.
good day.
Bye. Thank you. Awesome. Thank you. Bye. Awesome. Bye. Bye. And you guys, great job. You, Sonia, Jennifer, Camilla, Yasmin, Antonio. First of all, am I pronouncing all your names right? But are you guys good? Okay. You guys are good. Yes, I am kicking you. Thank you. If you got a question, that's good. Otherwise, I'm going to let the next class in a second. So